Hello everyone, I hope everyone's doing great. I just wanted to record a quick video for those of us who missed our Zoom call and just to help you guys fill out this worksheet. So I'll just, without further ado, help us get started. What we have on this top part is we have this left part, left column, which is our generic, our general ways that we wrote different reactions. And so we're going to fill these in as synthesis, decomposition, combustion, single displacement, or double displacement. And then we're going to use our generic ones to help us fill in some of these that are some examples. So without further ado, we have AB plus C goes to AC plus B. So this is an example of a single displacement reaction. The way this works is that our C comes in and it kicks out our B. So when we talked about this, we talked about people dancing together. A and B are dancing together. And then C is our bully and comes and kicks out B. So now that C's with A. So single, I like to look for this nice single element on either side that gets moved. This next one is an example of our combustion reaction. So this combustion reaction is the most detailed. For all our other ones, we have A, B, and C as any element it could be. But combustion has to be C and H plus O2 going to CO2 plus H2O. It has to be these exact elements and these exact, I guess elements is all I need to say there. So the next one we have is AB goes to A plus B. So when we start with something together and it gets torn apart into two separate elements, we have a decomposition reaction. The next one we have is AB plus CD goes to AD plus BC. So we can see that we start with AB and then we're switching where B and D are. And so since we're switching it twice, we're going to call this a double displacement reaction. And finally, we have A plus B goes to AB. So when we're forming two things, we're building together, we're making them. So this is going to be synthesis. And now let's use what we just did over here to help us fill out these. So every time we have a new capital letter, it's like a new variable. So another way to write this one would be A plus B goes to, let me copy this arrow, goes to AB, which is our synthesis reaction. This one, we can see we have oxygen, we have carbon, we have carbon dioxide, we have H2O for water, and we also have a CH4, so some kind of carbon and hydrogen. So it looks almost identical to this. The only difference is instead of having an X and a Y, we actually will have a 1 and a 4. So this is a combustion reaction. This time we have a Fe, so an H and an F goes to FeF plus He. So if we were to rewrite this every time we see a capital letter, we're going to put a new variable in there. So we have A plus BC, because we have H is capital, F is capital, goes to F we just said was A, H we said is B, so we're going to have to put C here plus B. So this one looks like our single displacement reaction. This next one, every time we see a capital letter, we're going to put a new variable. So we see Mg is going to be for A, Cl is for B, plus Na is going to be for C, S is going to be for D, going to AD plus BC. So, CB. So this will be a double displacement. And finally we have A for Na, Cl is going to be B, going to A plus B. So this will be our decomposition. So that's how we do our example, our types of reactions. The next part that we're going to review is balancing equations. So when we balance an equation, the first thing we always do is we put a 1 up here, and then we have to count how many hydrogens or oxygens we have on each side. So I'm going to call this side the left side because it's left of our arrow, and this side the right side. And then when I count them, I take this number that's on this line in front and multiply it by this number that it's a little bit below each letter. So we have 1 times 2, so we have 2 H's. We have 1 times 2, so we have 2 oxygens on our left side. On our right side, we have 1 times 2 for H's, and then we have a 1 times a 1 for our oxygen. So we actually only have 1. Whenever we don't see a number, we assume it's 1. Just like in math, when we have a x, a variable of some sorts, we never say it's 1x. We just say x. Or when we have y, we don't say 1y, we just say y. So we assume there's a 1 there. It's the same idea when we're counting our equations here. Alright, so we can see in this equation we have our H's are good to go, they're balanced right now, but our oxygens are not. So, excuse me. So now we have to balance our oxygens. So this is saying the right side we need to get to 2 oxygens. So in order to do that, I'm going to leave the left side the same. I'm going to keep my 1 and my 1 on my left side and only change my right side. So instead of having a 1, I'm going to try putting a 2 in front of it and count and see how that changes. So I still have 1 times 2 on the left side and 1 times 2 for my oxygens on the left side. Then for the hydrogens, I'm going to have 2 times 2, which is going to be 4. And then I'm going to have 2 times 1, which is 2. So this is good because I've balanced my oxygens, but it also threw off our hydrogens. But that's okay, we can keep adding numbers. So now that we have a 2 on the right side, we're going to leave the right side the same. We are balanced on our O's, so we don't want to touch anything that has an O in it over here. So we're going to leave this as a 1. But I need to get to 4 H's on my left side. So my left side is going to be this H, and to get to 4, I would need to do 2 times 2, which is 4. So let me count it again just to make sure. 2 times 2 is 4. 1 times 2 is 2. 2 times 2 is 4. And 2 times 1 is 2. So because everything is balanced now, we have just as many H's on the left and the right, just as many O's on the left and the right. We can say our full balanced equation is 2, 1, 2. Perfect. Alright, the next thing we have is MgO2, or Mg plus O2 goes to MgO. So we're going to always start by putting in a 1 in front of every number and then counting. So we're going to have 1 times a 1 for our Mg's, a 1 times a 2 for our O's, and then on the right side we're going to have 1 times 1 for our Mg's, and 1 times 1 for our O's. So we can see our Mg's are balanced, but our O's are off just like before. So let's leave our left side the same by leaving 1's, and we need more O's on our right side. So let's put a 2 and see what happens. We still have 1 Mg, we still have 2 O2's. Now we have 2 times 1 Mg's and 2 times 1 O's, which is 2. So our oxygens are balanced, but our Mg's are not. So let's not touch anything that has an O in it. And this time we need to get to 2 Mg's on the left side. So let's put a 2 there. So now that we have that, let's count again to make sure. 2 times 1 is 2. 1 times 2 is 2. 2 times 1 is 2. And 2 times 0 is, 2 times 1 is 2. So all of them are nice and happy. So we're going to write our final balance equation is the exact same as this one right here. But we just want to say our final answer is 2, 1, 2. All right. Next one is K plus O2 goes to K2O. Again, we're going to start with putting 1 in front of everything and then counting. So 1, 1, 1. 1 times 1 is 1. 1 times 2 is 2. 1 times 2 is going to be 2. And 1 times 1 is going to be 1. So this time, we see that they're both unbalanced. We need more K's on the left side, and we need more O's on their right side. So we can start by trying to balance either one of them. It does not matter. But because we've been balancing our O's first, let's just keep doing that. So let's get 2 O's on our right side. So we're going to leave the left side the same. We're going to still have 1 and 1. And then I need 2 O's. So I always ask myself the question, if there's a 1 right here, what times 1 equals 2? Well, 2 times 1 equals 2. So our left side's going to stay the same. We have 1K and 2 O's. Our right side's going to change. We have 4 K's. We have 2 times 2 to get 4. And we have 2 O's. 2 times 1 is 2. Great, we have our O's balanced, but now we need to balance our K's. So we're going to keep the right side the same. We're going to put a 2 there. We have our O's balanced, so we don't want to touch that, so we're going to leave a 1 there. And then our K, we need to get up to 4. Our right side has 4, so our left side needs 4. So I'm going to ask myself, what times 1 equals 4? Well, 4 times 1 equals 4. So we're going to go through and we're going to say 4 times 1 is 4, 1 times 2 is 2, 2 times 2 is 4, and 2 times 1 is 2. So we can see we're all balanced, and our final answer should be 4, 1, 2. So that's how we balance our equations. I hope that made sense. I know I went a little bit quickly through it, but if you have any questions, as always, please just let me know.